what I want to do next. I'm trying to do my own startup, so that's where I am right now. So fun fact, I love coffee, but the coffee here did not make me up yet. So this is a very quick agenda, so we'll just start off. I'm hoping that some of you might get. Let's start off with ML. What is it? Why you need browser-based ML? And what is TensorFlow? And we'll talk about the core concepts around TensorFlow and give you examples. And how do you do performance optimization if you're trying to use TensorFlow models? And we'll wrap it up. There is going to be a few demos. If I'm staring at it, it's not, I have to look into it for the camera to capture my face. So I just wanted to let you know. OK, first off, somebody here attended the previous talk. What is AI? What do you think? It is artificial intelligence. Don't tell me that. What does it do? Any ideas? It makes your life easy, right? And I'm sorry? Let's put it, this is a college area. Let's go down to that level and say that, OK, these are systems that are built making sure that it helps the task to be done without any human intervention, right? That's what AI is. It's on a larger picture. And what is machine learning then? Oh, it's not pixelated. I like the screen. So it is also a type of AI that teaches how these machines learn, right? It learns through interpretation and prediction based out of the information that you feed it, right? So just to give you, I think if you have attended my morning one, you would see this. So you have, on a larger set, you have AI, and that enables intelligence in systems. And then you have machine learning, which is the actual implementation. You make the algorithms. And then deep learning would be a class of algorithms that would drive the machine learning. So very small nutshell, giving you what are these terms, right? So what are the key ingredients of machine learning? The first one is data. Without data, it cannot do anything. It cannot predict anything. So that's the first one that you need. The second one is you need to have some kind of an algorithm. And the third one is how do you want to train it, right? So, and based on this, you can make a model, and you can make predictions out of the model. There are different types of models that are there. Different types of pre-trained model, I should say very specifically. Some of them are neural network models. Anybody heard of this? Oh, yeah. Oh, you spoke about it? OK.
I just spoke about licensing.
OK, we spoke about licensing. So there are different types, even in neural. This is very hard, I would say, as NNMs. So you have convolution neural networks, and then you have concurrent ones. You have long, short-term networks, too. These are different types of neural networks that can do some kind of predictions on, for example, the long-term, short, oh, I cannot even say those things. So let's start with basically they can do classification, recognition, and segmentation in a nutshell. So those are different types of neural network models. And if you see, for example, if you feed in data, if you feed in different images of, for example, you have husky, you have Labrador, you try to feed in all those images of those dogs. And then finally, you feed them, and the output should be not a fox. It should end up saying that you should have a dog, right? Some kind of a dog. And at least it should say a dog. So that's basic visual of a neural network model. And then there is a support vector model. These are used for classification and regressions, mainly for, for example, if you want to analyze proteins in a biological substance, right? For that, if you want to classify those, and for a text classification as well, and if you want to also use for sentimental analysis in financials, if you want to detect fraud or spam detection if you're trying to if you are an email provider or something like that. So you want to do a spam prediction as well, you can use this kind of a model, right? And there's decision tree model. As you can see, this classification is super easy, where it takes a regression test, and it often ensembles and like a reinforcement. Basically, a decision tree model is you want to make a decision, but if you want to make a single decision, you would use a single decision model. But then if you want to make multiple decisions across different decision trees, then you would use random forest. Very basic stuff. It's not huge. And just understand that these are the models out there. And clustering model. Of course, it is, again, used for classification, segmentation. When you put in a raw data for all these, I'm hoping that these are fruits. The top one looks like a tomato to me. So if you feed in these pictures, the algorithm has to predict which one is this, based on the clustering algorithm here, right? Now, shifting gears, why do we want to use browser-based machine learning? This is from the latest survey. I think it's from NPM Trends. I can't see this, sorry. There's a link. I can attach it to, I think, where's the survey? Stack Overflow, sorry. Oh, yeah, I did see the logo in there. My bad. So this is from Stack Overflow. This is a recent one where about 65% of the professional developers still use JavaScript, right? So that means we have to catch up a lot on browser side too. Who went for Web Summit AI or did watch the Web Summit AI from Google? There is a, if you want to go back, if you go to Google, YouTube, there is a Web Summit AI that Jason Mays presented. If you want to take a look at it, it's more on the upcoming technologies that Google is going to come up with. So why do we need browser-based machine learning? Because we need, I know it's faster, it's real-time processing, you're doing it on the client side, privacy and security is already there, and then it has offline capabilities, you can have service workers and stuff like that, and cross-platform, you can use different browser platforms too. And of course, you can integrate it with your current project. If you're working with, as a front-end engineer, if you want to use it along with your project, you can do that. So now, coming to the main topic here. So TensorFlow, it's a JavaScript library that you can use that can be used for training and deploying machine learning models on your web browser and in Node.js. Why I'm saying this, you will get it in a moment. So this is from Stack Overflow again. This looks very weird, but then see the overlappings of all these. If you see this, there's a lot of people overlapping that are using TensorFlow. But then I'm specifically interested in TensorFlow React, right? Because we are talking about, they're using it in React Native, which is OK too. And then a lot of people are using, this is just for TensorFlow, not for TensorFlow.js. But then this, overall, a lot of people are trying to use TensorFlow here. That's the whole idea. But then if you see other popular ones are, you have NumPy here, Pandas here, other stuff too, right? So this is from NPM Trends. If you see the number of downloads that over the period of time has increased over 1 million downloads from NPM Trends again. So having said that, it's consistently growing, and it's going to keep growing over the next few years too on the client side. So this is according to JS Deliver. So this is the chart. If you see the number of CDN downloads, it has grown. And this year alone, it's grown about 8%. So Google expects there's going to be a lot of increased usage over the years, and as more web developers are exploring this, right? So I don't know, can you guys see it? It's very pixelated. I tried to make it on my own, but it it did not come out well, so I thought, okay, I'll just copy paste this. So this is the architecture. At the top is the model that you would create. And this is the layer model where you will build layers of your model, right? Based on, it's like, again, a Lego piece. You put in piece by piece, and you create these. And then the core is, this is where the foundation of TensorFlow is. If you see, once you create this, you can save the model as a saved TensorFlow model. Here, the Keras model is mainly for Python. As a web or if you're working on the web and if you want to use the Keras model, you can still use it along with the Jed converter. I've not tried it, but personally, it is possible. And you can also have it under the client side. For example, you can deploy it on the browser, on an app like React Native, and WeChat uses it for as well. So, and then on the server side, you would still use Node.js, and you can use it along with WASM and WebGL too. So that is something that I wanted to talk. And then let's move on to the core concepts. Here, I'll be talking about tensor manipulation and how do you load a model and save a model. And then we'll see how to train models in the browser, if this thing allows me, because I have to switch. So before we get started, now let's, who takes mathematics or statistics? Anybody heard of this term? No? Okay, it's not a computer science word at all. It's a tensor is something. It represents, it's a data type that is, it's a data structure is called as tensor, but then it represents multi-dimensional arrays of numbers. So what tensors does is it has properties such as ranks, where you can rank from a scalar to a vector to a multi-dimensional one as well, and it has shapes, and it also has data types. So based on these properties, you can create tensors in your application. So why am I talking this? So for example, if you go to this JS Deliver and install TenzorFlow.js, if you can either deliver, you can have it inside of your script, or you can also download it. And you are creating a tensor here, and this tensor takes in the array here, and then it will say that, okay, the array would, it will deliver it as 1, 2, 3, 4 here, right? So that's how it derives, and this is how you have to use tensor inside of your application. These are nothing but rows and columns. And why there are a lot of operators available. I just wanted to mention mainly the reshape one, and most of the whatever operators you have it in JavaScript, TenzorFlow.js also has a similar one. The reason why I picked up reshape is TensorFlow, in TensorFlow, because I said that it is array-based, right? It's multi-dimensional. Even if you give it as a shape of 4, right? It could be either a square or a parallelogram. So if you want to predict your model based out of it, in that case, you can use reshape. So this is something that is there. I just want to point it out for why you have to use this. There are different models, like I told you, the layers API, when I showed you the TensorFlow architecture, I showed you the layers. So inside that, you can create sequential and functional. We're not going to be talking about the core API here, but I just wanted you to understand this is more complex, but this is doable. And let's talk about these two for the sake of time. So here, okay, this is a good one. So here we are trying to create a sequential model. And imagine that you are basically putting in, you are an assembly line of a car manufacturing company or something like that, right? If you are saying model.add, it just picks up a wheel, it attaches the wheel. And the second one would be probably you attach an engine, and then finally you compile it together. Understand that it's like an assembly line where you can add layers to each. So that's why I said you can add this, and then you can add. You have to, of course, pass in whatever you need to use it for your model. And then you compile it. This optimizer here is from TenzorFlow.js. It is called as Adam. And it also can predict the metrics, accuracy of it. So you can use or create your own sequential model using layers API like this. And then the other one is a little bit more complex, I would say. Here, imagine that you run a car factory, right? You don't run for, it's like you're branching it out for producing Hondas. And the other one would be Toyotas or something like that. And then once you do that, but then if you want to combine them, or if you want to put them in a line where you want to paint them together, right? So in that case, you would use a combined one, and then you can concatenate both the branches. I'm just giving you a vague analogy here. So understand that this is a little bit more complex one, but you need to know if you're using it, you need to, if you want to start with something, you can start with a sequential model. But it does give you a lot of flexibility to create your own custom architecture too. If you want to use pre-trained models that are available, right? First, what do you do? There's a lot of models available, so you can go install TensorFlow. Once you install, if you do run npm install, I think npm install TensorFlow, and then you load the model, you pre-process the data. I'll just show you a demo in a moment. Pre-process the input data, and then it predicts for it, and then it does a post-prediction. And you can, once it predicts after it post-processes the predictions, you can save the model. So here we are using this load layers model from TensorFlow, where you can use this pre-trained model, you can give the path to it, and then this model, you can prepare a data. Like I said, Tensor is the basic data structure that you would use in TensorFlow. You can make predictions, and once you make the predictions, you can also have the values out there. So, and I had a demo. Yeah, this is what I was looking for. This is a teachable machine. I hope I can open this up. I don't know how I can do this. Let's see. OK, this is, if I can open my web camera, give me a minute. OK, see here, I am here holding, here I have to say this as classifying this as a person, and then I can hold on and take pictures of myself. I'm doing this, doing this, doing that, doing that. And then I might also put while I'm recording, make sure that it's taking so many images of me, right? So this is how it's going to predict. OK, now we have about 312 images in a span of few seconds, right? And then let's classify another one. Let's take a phone. I hope I can. I'm going to be using my phone here. Hopefully this doesn't turn on my face. Here, oh no, not this. OK, I have to hold this. I'm holding this like this. So it's taking a picture, and when I'm trying to, oh, not this. I should have, hang on, let's delete this because I screwed up. How do I delete this thing? No, let's delete, delete, maybe add class. OK, good. Let's do phone, because I wanted to take the camera to phone, and then make sure. OK, hold. So I'm just doing this. I'm just doing this. So note that it is, if you have other buttons or whatever, different phones and with different camera lenses, here it has 203 images. And you can train the model, give it a few seconds. It'll It'll not let you close the browser. Hopefully, it is still preparing. There are some advanced things which it is still processing. But once it processes it, you can either export the model. It is still training. So it is almost done, I guess. Let's see. It is also contingent with the internet here. Hopefully, it works. Oh, it's still almost there. So it is training. 50%. Oh, yeah, this is what I wanted to make. OK, cool. Now we have this. So the moment I show my face, it predicts and gives the output as person, right? If I do this, it's still thinking. But then the more closer I go, it predicts well, right? So this is something that this model can do. And imagine how fast, within a span of 2 minutes, we were able to take 312 images of myself and then 200 images down there for the phone as well. Right? Now, let's switch gear. That was from Teachable Machine. You can all go try it. I can pass this information to you. The next one is fun. It's really cool. It is facial recognition one. It's based on facial key points. So if I go closer, you can see my eyes are showing up. And then this is based on the, and it should also see my ears too, ears, nose, mouth. So this is the key points you have, and based on that of it, it is recognizing. So even if I move, it still comes up, right? So this is another model. And there's one more, the last model that I really, really like is it takes a little bit of time, but this basically, what does it do is, let's see, load data, This recognizes letters, like numbers from 1 through 9. Let's see, hopefully it works. It recognizes each handwritten digit, and then it takes a little bit, it says training model, but once it starts, it is pretty fast. So, OK, see here, it says it's for how many, we are just, I can see this, only 20%. It is still loading, 16% it started training, but how many greens are you're seeing? See, it is recognizing by the time it predicts, you'll see within a couple of minutes, it'll predict all the letters, and it'll say, you know, that's something you can use it for signatures and all those things to protect your data too, right? Something around the lines you can use. There are people who go crazy, classify, they take leaves, images of leaves, and then they classify it. I saw somebody using spices as well. So different things you can use to create. You can use these pre-trained models, which are faster, as you can see, than having your own model too, right? Let's see. I think that was, oh, yeah. You are so curious. You want to do, OK, I don't want any of these pre-trained models. I want a model for myself, right? I want to do it. So can I do it? Yes, you can, but it comes up with some challenges. First off, you need to prepare the data. Can you do it faster? Like how you saw the images it was taking, if you're trying to do an image one. But then, again, for anything, you need a data preparation, right? And the amount of data it takes is also insane. And then how are you going to architecture? If this is not something that you have done, you have to find out. You have to read through if you want. The sequential model is for basic ones, but then if you want to go for the more advanced one, then in that case, you need to know how to architecture a model, right? And how are you going to train it, right? Based off of what? What is the algorithm behind it? And how are you going to deploy? Deployment costs money. Anywhere you want to use, then you have to pay money. So that is going to cost. So these are the challenges that comes with model creation if you want to create it by yourself. And now let's switch gear and talk about performance. So performance optimization. Why do you said, I talked about these models, pre-trained models, and if you want to train your own model, it comes up with a cost. So understand that in a browser-based machine learning, you need to have a fast model, right? And even if it's a little bit slow, how many of you open an app, if it's not opening up in 5 seconds, you'll just, OK, yeah, we do that, right? You don't want to use that app again. So that's something, poor performance will lead to a negative experience. and you lose your customers too. And it's also crucial when you're trying to use it for other, because web, you have to make sure that it's also available for mobile and other crucial devices, and making sure that it's also available in resource-constrained devices too, right? That becomes crucial if you want to do it browser-based machine learning. Okay, so this is with WebGL backend. So what I'm going to talk about is the data moves, your main thread moves from your CPU to GPU, right? And then it moves down to TensorFlow backend and then to the front end. After computation, the results come back to the CPU. This is the whole, this is how WebGL backend works. So this is how the data flow works, right? And here, if you see, by default, in the front end, you will have JavaScript clean up your stuff. You have garbage collection there, but in the back end, you don't have it, right? So this is where, if you want to use it, WebGL does not have such a method to collect the garbage. So in that case, you can use tensor.dispose. Or you could also use inside of your code, you can say the asynchronous function by saying, after this, tidy up, like clean it up, right? I think I'm doing a great job in finishing it before time. So what are the other things? If you go to this YouTube channel made with TenzorFlow.js, there's a lot of I loved one of these, the second video out here. I really enjoyed watching that. He's a radiologist who is using different images of radiology and then trying to make an image segmentation around it. And there are people who has used it with drums and other stuff. So if you are interested, if you're curious, see what others are doing, please go and take a look at this YouTube channel. And there are other demos. If you go to TensorFlow.org and demos, if you will see, this is where I took the teachable one, so the teachable machine. You can also try the other stuff too, right? So see what is it. And then there are a lot available on Kaggle. Who is in Kaggle? There was a 5-day workshop this week. Did anybody attend? You can still go to it. It is along with Google. I happened to sign up, but I never finished it, but I still got my badge. So I can, now at least I have the recordings to go and watch it, though. So because I registered. Most oftentimes I would register it, I would not have the time, but I go back to it and watch it. So Kaggle is a very good source where you will have all the Python models. You have a Python, we have a Python converter to TensorFlow.js. You can use that. And there's a lot of code labs from Google if you go ahead and take a look at it. And if you are curious, just use model, one of the models, TensorFlow model, and then convert it to JavaScript TensorFlow, and then you can use it as well. Oh, I read this article. It was fun. Actually, this guy is basically, he's an animator, right? And he uses this weird technologies. He uses ARKit, media pipeline, and TensorFlow.js to find out the facial expression on his animation characters. So look at, people are using these things in a very creative way. So that's one of the things I found out very interesting to read this. This is called extraordinary.tv or something like that. From that, I picked this up. And yeah, I'm almost done. So today we talked about what are these. And I also kind of covered a little bit on the TensorFlow.js too. Go ahead and check out all the demos that I showed you. It's all in, if you Google it, or else I can pass this on to. Once again, my name is Deepa. Thank you so much for your time. And this is the last talk of the day, and I'm very sleepy. Sorry about that.